Okay, guys, here we go on lesson 1-7. I wanted to go over these with you as well in case you had questions. Some of you were missing a few on here. So let's go ahead and go over the ones that were assigned to you. We're going to start with number 1, the try it problem. We have 6 is equal to the absolute value of x minus 2. So we always start by trying to isolate x. Let me make this a little bit bigger so we have some space to write here. So I'm going to add 2 to both sides. So I can work toward getting x alone. That'll cancel out my 2's. I now have the absolute value of x is equal to 8. So think about that. What can x be inside here? What would make it a true statement to get the absolute value of 8? What needs to be in there? Can either be an 8 or it can be a negative 8, right? So that's the answer to this. The solution is x can be equal to 8 or x can be equal to negative 8. But you must write both solutions down there. And you need to show me a little work there, how you arrived at your 8. Number 4, the absolute value. Oops, hold on, I'm going out of order. Number 2, let's work number 2. All right, so we're working toward isolating x. So I notice I have 2 times the quantity inside absolute value signs. So we have the absolute value of x plus 5 equals 4. Okay, so I want to undo the multiplication of 2. So I do the opposite or inverse operation by dividing. Dividing undoes multiplication. So I have x plus 5 inside my absolute value signs equals 2. Now, inside here can be, now think about this. If I asked you what can be inside there, you should say it could be a 5 or it could be, could be a 2 or it could be a negative 2, right? That would equal a positive 2. The absolute value of 2 is 2 and the absolute value of negative 2 is 2. Okay, so that means that what can be in here is either 2 or negative 2. So we're going to set up a couple little mini equations. The first one is going to look like this. We're going to take x plus 5. I'm going to pull them out of the absolute value signs right now just because I'm trying to just figure out how to make this inside equal to 2. All right, so I'm going to subtract 5 from both sides. I end up with x equals negative 3. And then my other little mini equation is going to be x plus 5. Remember, we said it could be a negative 2 in there. So let's subtract 5 from both sides. We have x equals negative 7. And those, my friends, are your 2 solutions to that problem. Negative 3 and negative 7. X can be either one of those to make that statement true. Number 3 is the absolute value of 3x minus 6 is equal to 12. Same thing. What can be inside here? What can that equal? Hopefully you're saying it could be a 12 or it could be a negative 12. Okay, so I need to do 2 little mini equations with what's inside the absolute value signs and set it equal to 12. And then we're going to do one that's set equal to a negative 12. Right? Because if you can solve this for 12 or negative 12, it would make the statement true. Think about it. 12 equals 12. The absolute value of 12 equals 12, and the absolute value of negative 12 equals 12. Okay, so I'm just trying to take what's inside the absolute value here, signs what's inside here, and make it 12 or negative 12. Okay, that's why we made the little mini equations. So let's work these out to completion. We would have 3x equals 18. We divide both sides by 3. X is equal to 6. There's one solution. And the other one will be 3x equals negative 6. Divide both sides by 3. And x equals negative 2. So your 2 solutions to that absolute value are 6 and negative 2. Now I'm going to move up here to number 4. I think that these are the papers my numbers got a little bit messed up on. I think I said it was the review sheet. I can't remember now. Let me double check. No, actually I do think it's the review sheet. Okay. Number 4, we have the absolute value of x is greater than 15. Okay, so we learned that x can be 15, or greater than 15 rather, because it's an inequality, or x can be a negative 15, right? But if it's a negative 15, it can't be greater than that because x can be greater than 15. So what it has to be is x can be less than a negative 15. So you do the absolute opposite when you work these inequalities out like that. When you're setting them equal to, or not equal to, but using the inequality sign that's given, you would take the first sign that you're given and then flip it around for the opposite number. Okay, so in order to graph this, we're going to put 0 in the middle and negative 15 down here, and we'll just stick 15 up here. I'll grab my red pen, and we're going to graph this. So x is less than 15, and x is greater than 15. Okay, so that's actually an or, isn't it? Okay, and if you remember, we had the go LA trick, remember? So if it's greater than, it's going to be or, greater than, or. And that's exactly what it is. They are not sharing points. Those inequalities reveal solutions that are in an or fashion on our graph. Okay, so actually we should have taken a moment to establish this first, because if we would have already in our minds begun to think about what our graph needs to look like. Okay, if you're an honors student, I'm going to hold these last two honors problems till the end. If you're not taking honors, it would still be to your benefit if you'd like to see it. It's nice to be exposed to it and to try it. But let's go ahead and move on to number 5. Number 5, we have the absolute value of x is less than or equal to 7. All right, here we go. So we have a less than LA, right? It's go LA. So LA is less than means and. So we already know that we should have an overlapping of points on our graph. So let's solve this. So x can be less than or equal to 7. That's what it says already. Or x can be what? With negative 7. Remember, we have to flip the sign now. So let's get this thing graphed. Here's 0. Here's 7. Here's negative 7. Let me grab my red pen. And let's graph this. X is less than or equal to 7. And x is greater than or equal to negative 7. So it shares all those points. This is an and, right? The graph reveals and because it's sharing points. Let's move on to number, oh boy, this really made a mess of my numbers. Oh no, it didn't. Okay, I know. These are coming out of the textbook. Sorry. Okay, now I remember. Number 15. This is in your text. All right, number 15. We have 2 equals the absolute value of x minus y. Okay, so let's see here. That's not a y, that's a 1. Saying that was looking really strange to me. Okay, here we go. All right, so I'm going to add 1 to both sides because I'm trying to isolate x, and what's in the way is the subtraction of 1. So in order to undo the subtraction of 1, we'll do an addition of 1. That will zero that out. Gives me 3 on that side, and I have the absolute value of x on this side. So where does that leave us? Well, I'm going to look at what x could be. X could be 3, right? Or x could be a negative 3. And that's the solution to that problem. Number 19 is the absolute value of negative 2x plus 8 is equal to 20. Okay, so we know that what is inside here can be equal to what? It can either be a 20 or it can be a negative 20. So let's write those out as little mini equations. I'm going to take what's inside the absolute value sign, set it equal to 20, and then I'm going to do another little mini equation that's going to be negative 2x plus 8 is equal to negative 20. So I'm going to figure out what x needs to be in order to make the inside of the absolute value signs both 20 and negative 20. Excuse me. All right, so let's just work this through to completion. Maybe you can try this on your own and see if we get the same results. The good news is the process for both mini equations here is the same. We subtract the 8 first, and then continue through there. Then we will divide by -2. And there's our two solutions. X can be a -6 and X can be 14. Because what that means is when I put a -6 back in, if I put a -6 in there, it's going to give me a +20. If I put grab another highlighter. If I put a 14 in there, it's going to give me a -20. So it makes what's inside the absolute value signs 20 and -20, and that would make a true statement. Number 23, we have 5 times the absolute value of x plus 3 plus 8 is equal to 6. So let's solve this to the end. We're trying to get x isolated. So we've seen many problems set up in this format, so we know that we should subtract this 8 first. We're going to have x times the absolute value of x plus 3 equals -2. From there, I'm going to divide by 5. We did a couple of these already. And I'm going to have the absolute value of x plus 3 equals -2/5. And I'm going to stop right there because I can already tell this is not a true absolute value problem. Why? Because if you look at the sign here, I have a -2/5. And remember, when you are looking to solve an absolute value problem, what is the answers out here is always positive, right? Think about it. Let's just take 3, for example. The absolute value of 3 is 3 because what it means is how many steps away from 0 are you? And both of these make a true statement, right? The absolute value of 3 is 3. How far away is 3 from 0? It's 3 steps. How far is -3 away from 0? It's 3 steps. But the answer that it produces out here is always positive. Well, here it's a negative. So this one has no solutions because there's a negative number. Oops. Sorry about that. I'm trying to write a negative here because of the negative number. You cannot have a negative number for your absolute value answer over there. Now, when I say answer, I'm talking about this. Solutions are different. Solutions are like these right here, the solutions to the problem. Okay, so that would be number 23. Number 25 is, oh, I have to pull my text out, so let me skip that one. Oh, wait a minute. I think we did that one in class, actually. I'm pretty sure we did that one in class. So, yeah, I think we did. So I'm going to go ahead and skip that one. We'll move on to number 27. Okay, so we have 2 is less than or equal to the absolute value of x minus 8. And that's it. Okay, so we're trying to figure out what x can be. All right, so here's what I notice about this problem. I'm going to have 2 solutions, remember. But I have to kind of, first of all, I'm going to look at what kind of a sign I'm given here. And the sign happens to be less than or equal to. So what did we say less than means? Less than, LA means and. Remember, go LA? So L is less than and A is and. So this is going to be an and, which means when I'm considering what's going to, my graph is going to look like, oh, but wait a minute. I'm looking at my problem ahead here. Hold on a second. Okay, hold on. Scratch what I just said there. Let's start from scratch on this problem. Okay, let's start over on this one. Okay, so I'm going to have, because what I want to do here is trying to figure out what I did when I worked this out, but I'm going to actually flip my entire inequality because I want x on the left-hand side. So I'm going to have the absolute value of x minus 8, and I'm going to put a 2 over here, but since I flip this thing around, I've got to flip my sign. Okay, now this has nothing to do with the rule that we've talked about, flipping a sign because I divided or multiplied by a negative number. I'm just moving this around like if this would have been x, let's watch this. If this would have been 2 is less than x, if I wanted to flip this around, then all of a sudden my sign has to flip, or it doesn't make sense. I've changed the truth of that statement. Okay, so that's all I'm doing. I'm flipping it around, which means I have to flip my sign around too. All right, so let's go back here. Hold on, I thought I just erased something. There we go. Okay. Now it's no longer an and that's what I wanted to point out, because I noticed I made a note here for or, and I'm thinking, why did I do that? But I see what I did is I wanted this on the left-hand side of my equation. That's all. So I flipped it, which would flip my sign. And I did that because I just like the x over on the left-hand side. Now, could I have worked the problem out the way it was? Yes, I could have, but I just did it this way because I think I just wanted my x on the left-hand side. It's as simple as that, quite frankly. Okay, so let's go ahead and work this through. But now I do want to pay attention, because I'm going to go ahead and figure out what my graph is going to look like here. So now I have, remember, go LA. So if it's greater than, it's or. So now I'm looking at an or, which means when I'm thinking about my graph at the bottom, when I get to that point, I'm going to have separate. They're not going to have any shared points. One's going to be going in one direction and one's going to be going in the other direction. So let's go ahead and solve this. I'm going to add 8 to both sides. I have the absolute value of x is greater than or equal to 10. Okay, so now I'm going to have x is greater than or equal to 10, or x is less than or equal to negative 10. Remember, we flipped the signs. All right, let me get my red pencil, and we're going to graph this thing. So I have x is less than or equal to, so it's a closed circle. There's the first one. And then x is greater than or equal to a positive 10. And there's what that would look like. So there's what our graph needs to look like. Here's our two solutions. You want to check that. There you'll have it. Number 31. And this is the last one on the homework for lesson 1-7. Okay, so this one is 2x plus 5 is greater than 9. Okay, so my x is on the left-hand side. No need to flip things around. So I'm good to go to make my evaluation of my sign and how my graph should be looking at the end. So here we are. We have a greater than again. Remember, go LA. Greater than is or. So this is going to be an or. So when I end up graphing down here, they're going to be going in two separate directions. They're not going to share any points. So let's figure this little mini equation out. So I'm going to set this equal to 2x plus 5 is greater than 9. Or 2x plus 5 is less than negative 9. And I believe it's got an equal sign underneath there. Alrighty, here we go. So I'm going to subtract 5 from both sides. Go ahead and work these out, see what you come up with if we have the same answers. Solutions, rather. Okay, so I've come up with two solutions. I'm saying that x is less than or equal to negative 7, or it can be greater than or equal to positive 2. So let's graph that and see how it turns out. Okay, so we're going to have a closed circle here on both of these. And there's what x is greater than or equal to 2 looks like. And then x is less than or equal to negative 7 looks like this. And notice it's or because they don't cross over. In other words, they don't share any points. That makes them an or solution. Okay, so that sums it up now for those problems for lesson 1-7. If you're an honor student and you would like to see help with 6 and 7, you can stay tuned. I would like for all of you to stay tuned, to be honest with you, because I think it's good for you to see these. These will be extra credit type problems sometimes that you'll see on your test. Honors that will be required for, and those of you that are in level 1 algebra, it would be a bonus worth extra points. So I think it's a good idea to at least try to work these out along with me. All right, so here we go. So we need to isolate x. So the first thing I want to do is subtract 8 from both sides. I'll have 2 times the absolute value of x minus 1 is greater than or equal to 2. I keep working this thing out, and I'm going to divide by 2 because I have a multiplication of 2 here, so I need to undo it by using division. And I have the absolute value of x minus 1 is greater than or equal to 1. And so now I have to ask myself, what can x be in here? We're going to make a little mini equation. We're going to do x minus 1 is greater than or equal to 1. And we're going to do x is, let's see, x minus 1 is, yeah, okay, less than or equal to negative 1. There's my 2 little mini equations. Okay, we flip that sign. Okay, now what I do notice is I should look again. See, sometimes I fail to do it too, but I should go back and look at this sign. It never turned around anywhere during my work, so it stayed as a greater than. And remember, go LA, greater than is or. So we're going to have another or here, which means that we're not going to share any points. So let's go ahead and graph this. I've got 0 here. We'll go ahead and we'll put... oh, we need to finish these to completion. Okay, sorry about that. I think my days get long, just like yours, right? Okay, so now I have x is greater than or equal to 2. That's one solution. And over here, I have x is less than or equal to 0. So there's my 2 solutions. So I'm going to need to build in a 2 here. Looking at my work here, I'm not sure why I have that. Okay, yeah, that should be a 2. Okay, excuse me. Alrighty, so let me grab my red pencil. So I have x is greater than or equal to, so close circle, 2, or x is less than or equal to 0. Close circle should go all the way down here. And that's what that graph should look like. Notice there are no crossing over of points. They don't share any of the same points. Okay, that is number, it shows us 6 here, and that shows us 5 on my printed paper, so I'm not sure what happened here. So you might want to double check that we're looking at the same problem together. The second honors problem here is negative 3 times the absolute value of x plus 4 plus 1 is less than 7. So let's take a look at this. So the first thing I want to do is just like the last one, we're going to subtract 1 from both sides. And we have negative 3 times the absolute value of the quantity x plus 4 plus 1 is less, oops, that's what I just got rid of, isn't it? Is less than 6. Okay, we're going to divide by a negative 3. Dividing by a negative, what does that mean? Think about that. Dividing by a negative means I'm going to have to flip my sign on the next step. So I have the absolute value of x plus 4, and I'm going to flip it because I'm dividing by a negative, and I get negative 2. I'm going to make 2 little mini equations here. X plus 4 can be greater than a negative 2, and x plus 4 can be less than a positive 2. Okay. Minus 4, minus 4. Let's work these out. So what you should have come up with is x is greater than negative 6, or x is less than negative 2. And I should ask myself, because there again, notice what I didn't do. Hopefully you're thinking like, Mrs. Quigley, stop. You didn't do any evaluating of the sign at the beginning. And sometimes the sign will flip. So if the sign does flip throughout the equation, excuse me, it may not be, it may not hold true to what we're trying to do here. So in fact, we actually did, we did flip. But in this case, I know the answers are correct here. Let's see, if it's less than, it should be or, right? Less than is or, but in this case, Greater than, oh, because we flipped down here, right? So if it's greater than, wait a minute, what did I just do here? Okay, I've done too many problems today. My brain's starting to feel like a little bit mushiness. Okay, when I first looked at the sign, let's talk through this together for a minute. When I first looked at the sign, I have a less than, which is LA, which is less than is and. It flipped down here, so it's go, because it's greater than or. But I know that on my graph, my points are actually being shared. So something happened. I might have to look into that for a legitimate answer to give you. How come that would happen here? And I think it might partially be because, I'm not sure. Let me do a little research on that one. I may have to look back in the lesson a little bit. But here we go. So I have, let's fill in what I have. So I have x is greater than -6. Let me grab my red. X is greater than -6, so it's going to go this way. And x is less than -2, and that's going to go this way. So the graph should look like this. But this actually reveals an and graph, which is actually what happened at the beginning here. But in other ones, and the majority of the ones that we saw where our signs flipped, it ended up changing whatever we had set at the beginning for our signs in the Go LA process. So I will check that out. This is actually done correctly, where your solutions are x is greater than -6 and x is less than -2. And the graph should look like you see it here. And my 0 doesn't go there. Yes, Mrs. Quigley's brain is getting tired. This is a +2. Let me move. I'll tell you what I'll do. I'm going to move. Let's leave that as is. We're going to move this. This should be 0, and this should be -2. There we go. Remember, we talked about productive struggle. Okay, so I'm struggling here, but I'm going to be productive about it. I'm going to go back and I'm going to find out why this, when the signs changed, why it didn't remain and go into an or description on my graph. So I will have an answer for you on that tomorrow, but the answer there is correct. So please get the notes that you need from here, and I will see you on Thursday. Have a great night, everyone. Thanks for watching.